The same two-line server initialization can handle both Descope and Scalekit authentication, but the configuration details make all the difference. You'll see how FastMCP's environment variables let you switch providers while keeping your code identical. For Descope, we'll use the inbound apps configuration in their console with Descope project ID and server URL variables, while Scalekit requires FastMCP server auth Scalekit provider prefix settings and an exact MCP URL matched to your server s/MCP endpoint. Both support OAuth 2.1 with dynamic client registration, but Descope implements it through remote OAuth while Scalekit uses enterprise SSO, with the server name parameter updating to reflect the active provider. From FastMCP, import FastMCP. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals my Descope protected server. This demonstrates the environment-driven authentication provider pattern, where FastMCP standardizes OAuth 2.1 integration through configuration variables while supporting different identity providers with distinct implementation approaches. Descope implements this through its inbound apps configuration, formerly called MCP servers, using remote OAuth with explicit dynamic client registration enabled in their console, while Scalekit focuses on enterprise SSO with automatic DCR, but requires precise environment variable prefixes. The pattern's distinctive feature is that your server initialization code remains structurally identical across providers, with only the environment variables and server name changing to reflect the active authentication system. The pattern works by using the FastMCP server auth environment variable to specify the provider class, with Descope requiring variables like Descope project ID and standalone server URL, while Scalekit mandates the FastMCP server auth SCLEKITPROVIDER prefix for all its settings, including MCP URL, which must exactly match your server's /MCP endpoint. Both providers enforce HTTPS in production and automatically validate JWT tokens, but their DCR implementations differ. Descope through explicit console configuration, Scalekit through enterprise-focused automatic registration. The server's name parameter appears in authentication flows and tokens, so it should accurately reflect the active provider, e.g., my Descope protected server versus my Scalekit protected server. This approach eliminates vendor lock-in while maintaining security consistency, as switching providers only requires updating environment variables and the server name, no structural code changes. The trade-off is the precise configuration requirements. Descope needs proper inbound apps set up in their console, while Scalekit demands exact environment variable prefixes and endpoint matching. The pattern excels in multi-provider environments or migration scenarios, with both providers supporting OAuth 2.1 with DCR, but implementing it differently. For debugging, both systems support logging and token inspection as shown in their respective documentation examples. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the provider-agnostic server class that implements OAuth 2.1 with dynamic client registration for both Descope and Scalekit. For Descope, configure inbound apps in their console and set Descope project ID, Descope base URL, and standalone server URL variables. For Scalekit, use FastMCP server auth equals Scalekit with environment variables prefixed FastMCP server auth SCLEKITPROVIDER, including MCP URL matching your server's /MCP endpoint exactly. The name parameter identifies the server in authentication flows and JWT claims. Update it when switching providers, e.g., my Descope protected server, right arrow, my Scalekit protected server. Both providers require HTTPS in production, with exact URL matching in their dashboards. Refer to the official ENV examples for precise variable names and enable logging for debugging as shown in the documentation. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals my Descope protected server. This initializes FastMCP with provider-agnostic OAuth 2.1 authentication, where the actual provider is determined by the FastMCP server auth environment variable. For Descope, configure inbound apps in their console with Descope project ID, Descope base URL, and standalone server URL, no Descope prefix. Then enable remote OAuth with dynamic client registration. For Scalekit, use FastMCP server auth SCLEKITPROVIDR environment URL. Client ID, resource ID, and MCP URL must exactly match your server's /MCP endpoint. Both providers enforce HTTPS and JWT validation in production. The name parameter identifies this instance across all authentication flows and appears in issued tokens, so update it when switching providers, e.g., my Descope protected server, right arrow, my Scalekit protected server. While the code structure remains identical, reference the official documentation for exact env configurations and enable logging for debugging as shown in their examples. Provider-agnostic authentication pattern. FastMCP implements OAuth 2.1 with dynamic client registration through environment-driven configuration, where Descope uses remote OAuth via inbound apps configuration, and Scalekit implements enterprise SSO with prefixed environment variables. Descope requires explicit DCR enablement in the inbound apps console with Descope project ID and Descope base URL variables, while Scalekit mandates FastMCP server auth SCLEKITPROVIDR prefixed variables, including MCP URL, that must exactly match your server's /MCP endpoint. The name parameter should reflect your actual provider, changing from my Descope protected server to my Scalekit protected server when switching implementations, though all other server code remains identical. Both providers enforce HTTPS in production with full JWT validation and support debugging through logging and token inspection, as shown in their respective documentation examples.
The authentication provider that never appears in your code appears in every token it validates.